All right, so today we're learning a concept called factoring. Has anybody ever heard about factoring? Of factoring? Okay, so like factoring in algebra. Yep. Factoring and algebra kind of go hand in hand. So if there was anything I remember specifically about algebra in high school, it's factoring. So we're going to just like kind of scratch the surface on factoring. Okay, so this is just kind of skimming the surface. But it's basically the distributive property in reverse. Okay, so you're going to kind of see how 3.4, there's a reason it comes after 3.3, the distributive property. Okay, all right, so somebody already said GCF, and you were exactly right. Factoring has to do with the GCF, the greatest common factor between two numbers. You see, if you don't pull out the GCF, which I'm going to show you, if you don't pull out the GCF, then you actually have to factor again, and it creates a lot more work for you. Okay, so when you factor expressions, you're pulling out the common factors between the terms. So it essentially is exactly what I just said. It's the distributive property in reverse. Okay? All right, so what is GCF? And how do I find it? All right. We are not even going to do factor trees. Okay. Factor trees take a lot more work, and upside down division works every time. All right. It's my understanding that you guys did learn this in 6th grade if you had Miss Smith. So upside down division says that I can only divide by a prime number. So remind me again, what is a prime number?
A number that doesn't have any multiples other than one itself.
Okay, so it has no other common factors except one in itself. So 2 is a prime number. 3 is a prime number. 5 is a prime number. What's the next one? 2, 3, 5, 7, 11, and then 13. You're really never going to go higher than 13, maybe 17, maybe, but really not here, okay? All right, so 30, I want to think of the smallest prime number that would go into 30, okay? So if it's an even number, what prime number do you know goes into it?
2.
Okay, so 2. All right, and how many times does it go into 30? 15, okay? Now, 2 doesn't go into 15, so now I'm going to go up to my next value. Does 3 go into 15? Yes. Does 5 go into 15? I'm sorry. 3 goes into 15 5 times. Does any number other than 1 and 5 go into 5? So as soon as you have a prime number at the bottom, you know that you're done. All right, so now let's do 48. All right, upside down division for 48. Does 2 go into 48?
Yes.
Do you know the easy mental math way to divide 2 by 48?
Cut it in half.
Okay, so divide each digit by 2. Okay, 4 divided by 2 is 2. 8 divided by 2 is 4. Okay, so if you're dividing something by 2, you can divide each digit by that number. 2 goes into 24 how many times? 12. 2 goes into 12 how many times? 6. And 2 goes into 6 how many times? 3. Okay. Now what you're doing is you're looking for a common factor between the two numbers. Okay. So you're looking for a factor to be common in both numbers. Do we have 2's that are common in both numbers? Yep. We have a set of 2's. All right. Do we have a set of 3's? Yes. Do we have a set of 5's or any other sets? No, we don't. Okay? We only have those 2 sets. So my GCF, I take each group and I'm going to multiply it 1 time. So it would be 2 times 3, which equals 6. 6 is the largest number that goes between the 2 numbers. So how does this apply to factoring? You have to do this method if you cannot figure out the GCF. Okay? Another way to figure out the GCF is to count multiples, okay? And we'll talk about that in a minute. All right? Not multiples, but just to mentally count factors. All right? Okay, so factoring out the GCF between two numbers. All right? So hopefully we can kind of run through the factors and figure out the biggest number that goes in between both of them. If you can't, then you do have to do the upside down division. But we're going to keep these numbers basic enough that we shouldn't have to do too much upside down division. All right, so we know that the GCF cannot be larger than the smallest number. It can't be a factor of a number if it's bigger than that number, right? There's no way the GCF's 28, right? Because it doesn't go into 18. So you always start with 18. Well, does 18 go into 28? No. Okay, so now let's go down to the next factor down. 9, okay? Does 9 go into 28? No. Okay, so I'm going to keep going. Factors of 18. All right, so 6. Does 6 go into 28? All right, so I'm going down the list. 5, 4, 3. What are y'all seeing? Is 2. There's no other factor that goes into it. Okay, so when you're factoring, what you do is you pull out that common factor and you divide the original term by that number. Okay? So what is 28 divided by 2? 14. So 14, and then you bring down your common variable, 14x. Okay? Now, what's negative 18 divided by 2? Negative 9. Now, there's a way that you can double check this. There's 2 ways, actually. First of all, if you actually hit the GCF, there will be no common factors between the 2 numbers that are left. Would you agree that there's no number that's divisible by 14 and 9 other than 1? Okay? So I know that I got the GCF. If there are common factors, then I know that I missed the GCF, which is what I'm going to show you next. Okay? Now, the other way you can check it. Remember, guys, factoring is the distributive property in reverse. So what is 2 times 14x? 28x. What is 2 times negative 9? Negative 18. So you see, guys, you're kind of pulling it apart when you factor, but then you can put it back together to check it. All right? Now, let's pretend for a minute that we miss the GCF on the second one. Okay? And let's pull out a 2 and see what happens with what is left inside. Okay? This is a way that you can check. So if we pull out a 2 and we think that 2 is the GCF, what's 4 divided by 2? 2y. What's negative 20 divided by 2? 10. Negative 10. Okay? So I think, okay, like this is my answer, but let me check it. Are there any other common factors between what's left, 2 and 10? 2. Yes, another 2. So at that moment, I know that I did not get the GCF. Okay? So if I had to pull out another 2, you said 2 is the common factor. I would multiply it by what I've already factored. So what's 2 times 2? 4. And would you agree? So I'm going to erase this. Okay? If you wrote it, you can just kind of make an X because that's wrong and just write underneath it. Okay? So pull out the 4 and now let's do the division. What is 4 divided by 4? 1y, or just y. What is negative 20 divided by 4? Negative 5. Okay? Now, let's double check it. What's 4 times 1y? 4y. What's 4 times negative 5? Negative 20. So you see, guys, factoring is like pulling my puzzle apart, and then distributive property is like putting it back together. All right, do you see how it kind of goes both ways? Okay. All right, so let's work on the next one. Let's just do the next one. Save the 36C for me to explain it. But I want you to try 15x plus 25. All right, let's see. Reese, what did you find for the GCF? Okay, do you agree with him?
Yes.
Okay, 5. Does anybody want to raise their hand and tell me what was left inside the parentheses after you pulled out the 5? Macy?
3x plus 5.
Did you guys get 3x plus 5? Just kind of nod your heads if you got 3x plus 5 inside. Okay, so I know that this is right. Did you kind of put it back together to check it? Are you guys getting the hang of that? So what's 5 times 3x? 15x. And what's 5 times 5? 25. Very good. Now, what do you notice that's different about the next problem? There's 2 variables, okay? So remember, I can only pull out the common factors. So do I have a common variable between the 2 terms? No, I don't. So now I'm going to try to target my largest factor between the 2 of them. So remember, we start with our biggest number. 24 does not go into 36, okay, evenly. All right, so I go to my next factor down, which is 12. Does 12 go into both of them? Yes. So I pull out my 12, and now I need to do my division. What is 36 divided by 12?
3.
Yep, 3, and then I bring down my C. So what's 24 divided by 12?
2. Capital D.
Yep, 2, and then my capital D, which I don't know why they made it capital. That might be a typo. Who knows? Okay. Yeah, I know. Usually variables are lowercase. Okay. All right, next. Okay. So I'm going to change my little tip here. Okay, my hint. Actually, we can leave the factor out. We're not going to factor out the smallest fraction. All I want you to do is factor out the coefficient. The coefficient. Makes it a little easier. Okay? I want you to factor out the coefficient. Okay? So write in that word, coefficient. What is coefficient? What is coefficient? It's the number in front of the variable. All right, so this is exactly how you're going to do it on your quiz on Wednesday. All right, and then tomorrow we're reviewing. Tomorrow we're just going to kind of sum up and review these 4 lessons. All right, so to factor out the coefficient, you're just going to simply say, okay, what number is in front of my variable, whether it's a decimal or a fraction? And you're going to pull that number outside the parentheses. Okay, whatever that number is. So when you divide the first term, it's going to be very simple. Any number divided by itself is what? 1. Okay, 1/2 divided by 1/2 is 1. So 1, and then you bring down your common variable. Now, the second one will require you to show work, always. Because what happens when you divide 2 fractions? I'm getting hungry. KFC. You need to show that step, even if you think you can do it in your head. Okay? So off to the side, I want you to do 3/2 divided by 1/2. Okay? I want you to go ahead and finish that work. All right, so this is going to be 3/2 times 2/1, which equals what? 3. So now that's what you bring down. But let me ask you this. Are you going to bring down a +3 or a -3? +3. +3. Why would it be +3 and not -3? Because 3/2 was positive. Okay, so do I know for sure that this is fully factored? Are there any other common factors
Prime numbers.
other than, yeah, they're both prime numbers, okay? Now, if I put it back together, 1/2 times 1x is 1/2 x. 1/2 times 3 over 1 is 3 over 2. Do you see how I did that? So it still works to put it back together. All right, so now I want to see who can do this next one. 3 over 4p minus 3 over 2. Don't think LCD. Don't think common denominators. You cannot combine these. You are factoring them. Okay, so totally different concept here. Factor out your coefficient and then see if you can figure out what's left inside. What fraction did you pull out? All right. Nod your head if you did 3/4 outside the parentheses. Did you guys do that? Okay. All right. So now you're going to start to notice a common theme with the first term left. If you divide a term, if that's the term you pulled out, don't you think it's always going to be 1? Yeah. Okay. So now we have negative 3 over 2. And I'm going to go ahead and times it by 4 over 3. So basically I took 3 over 4 and I flipped it. Okay. So now these cross reduce to negative 1 and 1. 1 and 2. Did you get minus 2? Did you get minus 2? Okay. If you messed up, do you see where you messed up? Okay. Did you flip your fraction right? Did you do 4 over 3?
I mean, because I was so confused because but you, for when it gets the distributed property part, the number outside.
Yeah.
It's always going to be the coefficient.
Yes. It will always be the number in front of the variable. Always. Is that the part you messed up on? Okay. Yeah, so don't worry about the smallest fraction. We're just going to pull out the coefficient for all rational numbers. Okay, so anytime it's going to be a fraction or a decimal. Which leads me to the next example. All right, what do you notice that's a little different about the way these expressions are written? What do you notice that's a little different?
The variable's not.
Yeah, the variable's not first. Okay. But let's think about this. Do you think that really is a big deal? Could I use commutative property and flip it around? Absolutely. Okay, so if you don't like how that looks, you could easily do 2.5q. Would it be plus 5 or minus 5? Plus 5. Okay, I didn't change anything. 2.5q is still positive. 5 is still positive. And I'm going to ask you to factor out the coefficient again. So what number is in front of Q? 2.5, okay? Now, if you cannot divide the second term, if you're having trouble, okay, you're going to have to do some quick long division off to the side, just like we divided our fractions. We might be able to do 5, though. Does anybody know what 5 divided by 2.5 is? Just hold up how many fingers you think it is. It's 2. 5 divided by 2.5 is 2. Now, if you need to just double check that, we would say 5 divided by 2.5. We can't have the decimal in the divisor, so we bump it out. And 25 goes into 50 2 times, okay? So now that I know it's 2, I'm going to say plus 2 inside the parentheses.
Is this our final answer?
This is your final answer. There are no other common factors inside my parentheses. Are you paying attention? Okay, there's no other common factors inside your parentheses. And I pulled out my 2.5. Could I put this back together?
Yes.
What's 2.5 times 1q?
2.5.
2.5q. What's 2.5 times 2? 5. So I'm back to my original problem. Okay, so that's how I can check it. All right, so what about 42 plus 3.5h? I want you to try to pull out your coefficient and then divide to see what's left inside. You can flip it around if you want, or you can leave it just how it is in that order. right, Mariana, what number did you pull out outside the parentheses? 3.5. All right, did you guys do that? Did you pull out 3.5? We'll just leave it in this order, okay? Now, 42 divided by 3.5, that's a little tougher, okay? So let's just do that division, okay? 3.5, I know I have to bump out my decimal, which makes this 420. How many times do you think 35 goes into 420? Well, actually, 35 goes into 42. How many times? One. Okay. And then you got 35 and then a 70 left over. So 35 goes into 70 how many times? 2. So that's going to be a 12. So 12 plus what's going to be left with the H? 1H. Okay. And that's going to be my answer. And then, of course, I could do the reverse to double check and get the same answer. You don't have to do the checking. It's just a way that you can make sure that you're right. Okay, how are we doing, guys? Thumbs up, thumbs down. Yeah, okay. All right, so now let's factor out a negative number. Here's the good thing about negatives. And again, because this is just your first introductory into factoring, when it's a negative, they're going to tell you what number to pull out. Okay, so they're literally going to say, factor this number specifically out of the expression. So you automatically know what number goes outside the parentheses. There's no guessing. You don't have to figure out, okay, what's GCF? What do they want me to do? They specifically tell you what number to pull out. Now you're just going to do the division. So be careful on your positive and negative rules. What's negative 4 divided by negative 4? Positive 1. Positive 1. Okay, so 1p. Just bring down your p. Now, what is 10 divided by negative 4? Is that going to be even? Is that going to be an even number? Okay, or like a number without a decimal? No. Okay, so you can come over here to the side if you need to do some division and do 10 divided by 4 and see what you're going to come up with. Now, these division problems are not going to be crazy decimals. You don't have to worry about the decimal being like this ridiculous, really long number. 4 goes into 10 how many times? 2. 2 times 4 is 8. Can't have a remainder, so add my decimal. And 4 goes into 20 how many times? So 2.5. Would it be plus 2.5? I want everybody to write it down on their paper right now before I say it. Would it be plus 2.5 or minus 2.5? Write it down on your papers. Get you an answer down. All right. Nasir, what do you think? Plus or minus? No. Nope. So it's going to be, help them out, guys, plus. Because look up here. Because it's plus 10 in the original. So it stays positive. Whatever the sign was in the original, it was plus 10.
For real?
Yeah.
Oh,
Yeah. Oh, I'm sorry. Hold on. It has to be positive. I messed that up. Nasir, you were right. Because when you do it in reverse, a negative times a negative has to be a positive. Oh, my word. See? Those negatives can mess you up, especially at 8 o'clock in the morning. Okay, so go ahead and try your next one now. Okay, factor negative 5 out of negative 5d plus 30. So if I pull out negative 5, what would I need to multiply negative 5 by to make it equal negative 5d? And again, you can do your division. What's negative 5 divided by negative 5? Positive 1d. And what's positive 30 divided by negative 5? Negative 6. And when I double check it, negative 5 times 1d is negative 5d. And negative 5 times negative 6 is my positive 30. Okay? All right. Do okay on that one? I messed you up too much on the first one. Okay, so now I've got a rocket launch pad. Has anybody ever seen a rocket take off like in person? We live kind of close to NASA. I've never seen one either, not in person. But has anybody yet, you've seen one in person? That's actually awesome. Okay. Have you ever gone outside in your backyard when the rocket was taking off and you could see it taking off in the air? So obviously, it's not just taking off like from a field somewhere, right? They build a huge launch pad to withstand the force of that rocket taking off and all the fire and everything that's coming out of the rocket.
Remember that day where you could like see Saturn or something?
Yes, that was crazy.
That's the last thing I can remember.
Yes, that was crazy. Okay, so now we're going to add a little twist to this factoring thing. I know that the width. Okay, let's back up a minute. How do I find the area of a rectangle?
Length.
Area
Length.
equals length times width. You've got to know that as like some of your background knowledge, okay? Area equals length times width. So here's what it does though. It tells me what the area is, okay? So I'm just going to kind of flip this around because I like my total to come after the equal sign. The area, what? The area is 6W plus 360, okay? So that's my area, all right? Now I know that length times width equals that, okay? So length, which I don't know, times the width. So do a capital L because little l looks like a one, okay? So now I'm gonna write this. I'm gonna flip this around. Does everybody agree? Length times width is the same thing as width times length. Okay. So 6 times what value for length would be 6W plus 360. Okay. So here's what you're gonna do. Just like we just did on the last one in all my factoring. You're going to divide the end numbers by the number that's on the outside. So what's 6W divided by 6? 1W. What's 360 divided by 6? 60. Okay? So this is your length. If 6 was your width and your whole area had to be 6W plus 360, then your length is 1W plus 60. This is your answer.
So when we did L times 6, is
that was just length times width, but you need to write it in reverse. But I was just showing you that length times width is the same thing as width times length.
Capital L times
Yeah.
6, is that
It doesn't. It's. I want you to start off by writing it like this.
I didn't know how we
Yeah. Yeah. Okay, now you have to know that to answer this next question. Okay, so here we go. Here's our tips. It's a rectangular landing platform, which means, what is my formula? Area equals length times width. Okay, so the rectangular platform is 60 yards wide and has an area of 60x plus 3,600. So before we even try to answer the question, what information is it missing? It's missing what did we just solve for? It's missing the length, okay? You need to know the length and the width here to be able to answer the question. So we're going to set it up the same exact way, except now it's 60, okay? That the width times the length that I don't know will equal my total area of 60x plus 3,600. Okay? And here's what I'm trying to do. I want you to just kind of draw like a rectangle off to the side. All right? Let's talk about the dimensions here. The width is 60 yards wide, right? Right? What does it ask me to solve for? The perimeter. So I have to figure out what the length is in order to be able to answer the question. which is why I'm setting this up here. The only reason I'm setting this up is to try to figure out what my length is. Okay? So let's do my division in reverse. What's 60x divided by 60? 1x. What's 3600 divided by 60?
600.
Take one of the zeros off. 60 plus 60. So my length is 1x plus 60. I'm going to draw that in to my visual model. 1x plus, I've got to have my other zero, plus 60. And 1x plus 60. Now I'm ready to answer the question. It says, write an expression, distributive property, that represents the perimeter of the platform. Perimeter equals, does anybody remember my formula for perimeter? Say it with me. 2 times the length plus 2 times the width. So perimeter equals 2 times what? What's my length? 1x plus 60 plus 2 times 60. You're almost done. Now you need to distribute. Simplify. Simplify. Okay, see if you can get a step ahead of me. P equals, what's 2 times 1x? 2x. And what's 2 times 60?
120.
120. And what's 2 times 60 again? 120. Okay, so that's my final answer, right? There's nothing else I can combine?
No, the 120.
The two 120s. So here's my expression. Perimeter equals, don't y'all feel so much smarter? 2x plus 240. Okay? That one's going to take a little bit of practice. There was a lot going on there. How do you feel about solving it backwards to figure out your length? Because we did that one twice. Okay? So we're just going to need a little bit more practice on that, which is why we have a whole review day tomorrow and why we still have 10 minutes left in class now to work on homework. All right, so that's everything you need to know for today's lesson.